Good morning, everybody, to the first talk of the Education Summit this morning. Would you please welcome Ben Nuttall talking about physical computing with Python and the Raspberry Pi.
Morning, everyone. Welcome. Great to be back at EuroPython. This is my talk, Physical Computing with Python and the Raspberry Pi. My name is Ben Nuttall. I'm from the Raspberry Pi Foundation. We've got a series of talks today, so we just had Carrie-Anne's brilliant keynote, and we've got a few talks lined up in this track related to education. And it's the Education Summit. This expands to this weekend as well. We've got some sprints and education stuff, trying to crack on with Carrie-Anne's list that she's given us all to do. So a bit about me to start. I'm an education developer advocate at the Raspberry Pi Foundation. I do software and projects, kind of develop stuff internally, and I write learning resources that go on our website, the free and Creative Commons learning platform we have there. We run teacher training courses with something called PyCademy, and I do a lot of outreach, go to a lot of conferences and stuff. We're based in Cambridge in the UK. That's me on Twitter, Ben_Nuttall. And if you were at EuroPython, PyCon UK, PIS, PyCon Ireland, or EuroSci-Fi last year, you may have seen me speak. So just a quick update. So since I was here last year, the news is related to hardware. We've now got the Raspberry Pi 2, second generation Raspberry Pi. It's now a 900 megahertz quad-core ARM v7 with a gig of RAM. It's backwards compatible and exactly the same shape and size as the previous model, the B+. We kept it at the same price, which is $35, and reduced the old ones down to $25, and the A+ is $20. So we are an educational charity, as Carrie-Anne's just been talking about. It's not something that kind of came afterwards and kind of got bolted onto a computer company or a hardware company. The idea was originally to help education, and that's why we wanted to create something to empower young people and give them a possibility to learn programming skills and learn about computing from an early age in a kind of sandbox environment. They've been on general sale since 2012, and they've been made available worldwide to everybody who wants one for the same price. We're not limiting this to just children or just the developing world. It's the same price for everyone because that's really helpful to have that whole community around the Raspberry Pi. I'll give some examples. We write free learning resources for makers and educators, and as I say, we have this PyCademy, our teacher training CPD course, professional development course, currently in the UK. We've run a few around the UK, and we're taking it to the USA next year, and we'd like to see more things like that around the world. So a couple of stories to start that are kind of about our community and about our origins and how things have developed over the last 3 years. Ben Croston is a guy in the UK who brews beer, and he wanted to use a Raspberry Pi to control the beer brewing process and kind of monitor it from his phone, have a web app running and that kind of thing. Chose the Raspberry Pi and chose Python to write it in, so he started to develop a platform which allowed him to communicate over the GPIO pins. I'll explain more about those in the next few slides. And that project became, it kind of output a library. It became a general purpose library for that's how you talk to the GPIO pins from Python. Another example, Dave Jones, also in the UK. His wife's a paleontologist, and she wanted to use a microscope to do some fossil photography and that kind of thing. And the problem was that the university's microscope was a real palaver to use, and it sort of stored it to an external drive somewhere else on a network that you had to then get permission to access, and it was a real pain. So he said, just stick a Pi camera on the top, and then you'll get the pictures straight out and be able to use them. So he built a little web app that allowed her to kind of monitor and deal with all the pictures that came out of it and archive them. Again, this became the general purpose Pi camera library, and it's a fantastic resource for anyone who wants to use the camera for anything, and he's been working on it ever since. In fact, I told him recently, because I kind of talk about this in a lot of my talks, and I said, oh, by the way, I always use you as an example of when I'm talking about community at the conferences. about how you created the web app for your wife. And he said, oh, did I? Is that why I started? Oh, I ought to finish that. So Raspbian is our Linux distribution that we use. It's a Foundation-issued Debian-based distribution, currently based on Debian Wheezy. Jessie is now kind of stable, so we're going to be moving to that shortly. The image that we provide supports Pi 2 and Pi 1, even though they're different architectures on 6 and 7. But we make sure that we still support our old users on the old platform. We pre-install certain software on that image, so you get the Python interpreter, you get idle, unfortunately, and a bunch of other stuff. There's Ruby on there, Sonic Pi, Java, Mathematica, and stuff like that we kind of put in the image and create it so that you can use it out of the box. We have other things as well that are kind of community contributed. So the GPIO library and the PyCamera library, for instance, are examples of what's already installed. And once we move on to Jessie, it will be a lot easier for us to ship with pip pre-installed. There's alternative distributions available. So Ubuntu, now we're on ARM v7, also works, but and there are other ones like Arch Linux. But we support Raspbian ourselves and maintain that ourselves, and all for educational and general purpose use, we recommend Raspbian. You can get that from raspberrypi.org. So the GPIO pins, so this bank along the top there, we refer to as the GPIO bank. Now, strictly speaking, they're not all general purpose, so they're called GPIO, general purpose input output. Strictly speaking, they're not all general purpose. So you can see this is a little accessory somebody made. Our community is full of cool stuff like this that people create and put on sale, and there's whole businesses around this. But this is a little pin diagram that you just stick over the top of the pins there to tell you which pin is which. So you can see here there's some 3-volt pins and some 5-volt pins, some ground pins, and then these ones are GP and they have numbers. So the GP19 is general purpose pin 19. And those ones you can control. You can have inputs or outputs, listening for inputs or sending outputs. You can wire things up to those to do physical computing. Analog, so there's no native analog pins on there. They're all digital pins, so ones and zeros. But there are options if you want to use analog inputs with Raspberry Pi. So you can use an ADC to convert analog into digital. There's various Arduino-compatible add-on boards available. And there's also Pi Serial, the Python module, for reading Arduino pins over USB. So let's have a look at the RPi GPIO library. So this is included in Raspbian, and the implementation is in C. The features are you configure pins. So you give a pin number and you define that pin to be an input or an output, and then you can change them in your script. You can read the inputs, so you can say, is this one high or low? You can just get the value of it. And you can send outputs, so you can say, turn this pin on if it's an output pin. There's also a feature called wait for edge. So an edge is when something changes from high to low or low to high. And you can have a script that sort of pauses and waits for something to change, like wait for the button to be pressed and then continue. And there's event detection with callbacks. So you can run a function on the event of something happening, like a sensor going off or a button being pressed. So there's a lot of this is kind of fundamentals of everything you might need in such a program. So just a quick example. We've got some stuff on a breadboard here. We have a circuit putting 3 volts through an LED and through a resistor to limit the current. Then we have it going back to ground. So that just completes a circuit. There's lots of little bits of basic electronics that kind of help you with these sorts of projects. I don't know an awful lot about this, but just enough to get by. This is just a complete circuit with an LED in it, and putting 3 volts through there that gets current limited through the resistor just means that this is always on. So I can't change this in my program. It's just connected to always be on because it's sending 3 volts through. If I move that from the 3v3 pin to GPIO 2, then I can write a program which turns pin 2 on and turns pin 2 off. So this is what the code would look like. So we import the GPIO library. We set the mode, because annoyingly there are 2 numbering systems for the pins, because, one isn't enough. So we set the mode to BCM, which is the actual numbers that they are according to the chip. So the GP2, GP3, GP4. So we set the mode, tell it which mode we're using. I'm using a variable here just to say which pin I'm using, which pin represents the LED. I set up that pin as an output. And then here's just a little bit that just goes, turn it on, sleep, turn it off, sleep, in a loop. So that's just flashing the LED on and off. This is really empowering especially for young people or for anyone. Instead of just having something saying print hello world or fry in range 10, print I, this is something flashing, something in the real world, something physical. This is another example. A simple circuit where we've got a button going from GPIO 17 through to ground. So just complete a circuit there. We can listen on pin 17 and wait for that button press. So this is what the code would look like. In this case, I'm actually using the PyCamera library, so the button is going to trigger the camera to take a picture. So this is just the setup. So we have our set mode. Button is pin 17. Set up pin 17 as an input. And this is the pull. That's wrong, actually. That should be pull up or down. So sorry, this is. So we set it up. We tell it which pin, what it's going to be, and then here should be GPIO pull up or pull down. And this is an electronics, bit of electronics which determines whether a floating value, like a digital input, is you kind of send it to high or low, and then you wait for it to fall. If you've pulled it up, that means it's been pressed, and if you've pulled it down, you wait for it to rise. So this is a mistake. So here and then following on, so that's our setup, and following on we have, with the camera, so with an instance of a PyCamera object, we start the preview, which means you see what the camera sees in real time. Then we have a loop which just says, wait for that button to be pressed, wait for that to fall. So I would have pulled it up on the previous slide. And then it just sits and waits for that button to be pressed on 17. Remember, this is 17. Wait for that button to be pressed and then continue. So it would go onto this line and capture a frame, then iterate round, incrementing the frame number, which would go into this bit here. And then, this is pointless because it's a wild true, but you could have something to catch that to exit, like a second button, or just a keyboard interrupt. Another example here, we've got, this is for a GPIO music box. So instead of wiring up just one button, we wire up 2. So we have 2 buttons. We've got one going to GPIO 2, one going to GPIO 3. Then I create use add event detect on that button, looking for a falling edge, because I've pulled it up. The callback is the function I've defined as play, and the bounce time, which means how long it takes before it lets another event come in. 1,000 milliseconds, so 1 second. So I would have a function here that called play, which I've defined as my callback. And then all I'm doing here is saying when this is called and it passes in the pin number that actually triggered the event into the function, I look up which pin in here, and I get, this is a Pygame sound object, and then I can just go sound.play. So I know which pin was pressed, 2 or 3, according to which one. So I would do this on both buttons. Then look up which sound to play and play it. Really simple, straightforward example of using events for multiple button presses and doing different things according to different inputs. There's something great for these types of projects, which are really kind of small and simple, but really empowering and really can be really interesting and engaging. They're called the CamJam kit. They're just a collection of little bits, really useful bits for lots of these types of projects. This is kit 1, which has a breadboard, some buttons, lights, and resistors, and wires. And this is kit 2, which has a load of sensors. So it's got a passive infrared sensor, so you can use that as a motion detector. It's got some LEDs, a buzzer, and some other bits in the breadboard. These are really cheap, so these cost £5, and this one costs £5, this one costs £7. So really kind of pocket money electronics. And they come with a bunch of resources that you can follow along, and these are just put together by one of these Raspberry Jam, the community events, in partnership with one of the Raspberry Pi community resellers and accessory sellers. They just got together and made this really cheap and tried to put it out there for more people to get involved in this sort of thing. So once the Raspberry Pi came out, there was a lot of add-on boards and accessories have been brought out. This is one of the first ones, one of the early ones, by a guy called Gert. He's actually one of the chip architects at the company that made the chip that we use. He's very knowledgeable about Raspberry Pi, and here's him teaching me to solder while I'm wearing an elf hat. He made this board called the Gert board, which is, he's an engineer and he thinks this is exactly what people need. This is an amazing board that gives you loads more potential to get out of your Raspberry Pi. It's got all this stuff on it. And, technically he was right. That's a really cool board and it can potentially do all these things, but he didn't provide any software for it. And he probably just put, here's a C program which you can use for this mini project. And another barrier to this was that initially it came unsoldered. So you would buy a kit like that and you'd have to solder up all of that entire board, and then there was no software and no examples really to use it. So a lot of people kind of get turned off by that sort of thing because they want to get going. So I'm going to go progressively through kind of good examples. So this one is a young lad, actually. He was about 17 when he created this, called Ryan. He created a little add-on board that just does one thing really well. It's just a little motor controller board. So you can drive motors, so you can use it in robotics. He doesn't provide any software for this, but no bespoke software, but he shows you how you can use the GPIO library to drive the pins forward. So you can, as long as you know which pin is which, so which pin it's connected to, he will just say pin 17 is the left motor forward, or pin 18 is the right motor back. Then you've got enough to go with, and you just write a little bit of code, similar to the examples I showed you earlier, just turning pins off for a certain amount of time, and it will drive forward, or spin around, or whatever it is that you've asked it to do. So that's kind of cool, and a nice learning, nice, not too steep learning curve. This is another example, which is kind of further along the spectrum. It's a little add-on board that has 3 LEDs, colored like traffic lights, has a button and a buzzer, and a bunch of extra inputs on the front as well. They provide a software library for this. So import Barria, you've got a full abstraction away from which GPIO pins things are connected to. You just refer to them by the light and the color. So you just run this function, Barria.light.green.on, the green light comes on. Instead of GPIO output 17 true, you have turn the green light on. This is a really nice abstraction, especially for young children to get involved, even less of a steep learning curve. There's plenty you can do with this as well. They've even got event detection, so you can create a function that flashes it. So turn it on for 1 second. So this is actually all the lights, because I didn't specify a color. Sleep for 1 second, then turn them off. And then I can say when the button is pressed, run that function. So when I press the button, flash the lights, all the lights on for 1 second. And there's loads of places you can take this. This is an add-on board called Energini. It's a company that makes remote control switches, so you can buy a remote. You can turn off the Christmas tree lights without having to get right behind it. Then they made a Raspberry Pi add-on board, so this just sits on top, and they provided you a massive file with about 50 lines of Python saying, this is how you turn switches on and off. We had a young girl with us on work experience. She was about 15. We said, can you take a look at this code, kind of tidy it up, work out the logic, and and then put it into a function that you can turn them on and turn them off. Because 14, 15-year-old girls are better at programming than the people who make this thing. And then I packaged it and took all the credit and put it on pip. So you import Energini, switch on and switch off. You can pass in the number of, if you've got a bank of 4, 1, 2, 3, 4, you can turn on the sockets arbitrarily with numbers. I also made a little web app to show that you can do this sort of thing. So this is just a basic Flask app, which is on the documentation. That you just press that on your phone to turn them on or turn them off. And that was running on a local network, but if you configured your router correctly, you could do that over the internet. And there's plenty of services to help you do that as well. So a bit over a year ago, we moved from the original Raspberry Pi, this one, the original Raspberry Pi Model B, to the B+. So this was still Raspberry Pi 1, but it was a plus version. And we extended the pins from a 26-pin to 40-pin, so you get a lot more to play with. So the examples I've shown you so far of hardware would sit on the 26-pin bank, and they still work, because the first 26 pins are exactly the same. But we also defined a specification for add-on boards. People don't have to follow this. They can still make 26-pin ones. They can still make 40-pin ones not following the rules, but we call these hats. So it's hardware attached on top. So Raspberry Pi hats are the name of the official specification for add-on boards. It has features such as you can use ribbon cables like this if you cut it out, and if you put it in exactly the right dimensions, it will fit nicely on top of a B+ or an A+ or a Raspberry Pi 2. And you can use mounting holes, because we've used the mounting holes with screws to just hold it in place. One of the projects we worked on last year was looking at sous vide cooking, which is where you get a vacuum-packed food, such as steak like this, and you cook it in water at a very precise temperature. So we decided to design some hardware to do this. We did some prototyping first with breadboards and stuff, and then we had somebody create an actual hat for this. So if it's a hat for cooking, it's called the chef hat. So it was like this. We used the Energini to remotely control the cooker. It's kind of dumb, really, in that we're just using a temperature sensor in the water, and if it's too high, if the temperature's too high, we turn it on. Too low, we turn it on. Otherwise, we turn it off. There's a little library that I'm working on. It's a work in progress. We have another board called. These are just some kind of internal projects that we've been working on. There's one called the DOTS board, which uses conductive paint, and there's a load of little holes on this board, little dots on this board, that you use the paint with a paintbrush to draw a pattern to connect the dots. We tried this out at a couple of events. We went to Maker Faire and South by Southwest, and got really young children engaged in doing something more interesting than just typing on screen. So they sit there for 5 or 10 minutes, just drawing out their plane really, really intricately, and then they take it over to the Raspberry Pi, stick it on top, and then they run a Python program that draws a plane in the colors that they chose along the top, which is kind of really, really novel idea. And this is some of the part of the software, and all we do here is, so we have a pin is active function, so we just check whether, given the list of pins we know to be the aeroplane pins, then we just count how many of them are active and not. So just by putting paint over them connects the outside of the dot to the inside, which shorts it to ground, which you can detect in software. And then we just have, how many of them are connected. And if enough of them are connected, we show the plane. It was a little Pygame app. Another one, the plant pot greenhouse. So this is a beautiful looking board designed by Rachel Rains from Raspberry Pi Foundation. And it's, so this bit, you kind of clip all of these bits out. So this bit sits on top of a Pi that's kind of hat-like. And then you have a wire running to the sensor board, which is this stick here. You stick that in soil. It's got a soil moisture sensor, a light sensor, and temperature and humidity, and you just use it to monitor the conditions of the plant. You put it inside a little acrylic kind of greenhouse thing, So the Pi is inside there, and then LEDs on top of the board glow according to whatever you programmed it to do, according to whether it needs watering or something like that. This is one made by an amazing American company called Adafruit, the capacitive touch hat. So you stick this on top of the Pi and you wire up crocodile clips to each of the pins, to each of the holes on there. And then you can, there's a bit like Makey Makey where you can build a piano with fruit or something like that. So you wire that up to anything, and then in Python just read which ones have been pressed, and then have different actions according to that. There's a bunch of really cool hats made by the community and made by these companies that have accessories. Pi Moroni is a brilliant example. They were one half of the team that built the Pi Barria that I mentioned earlier. This is the unicorn hat, so it's a nice 8x8 NeoPixel grid that you can program really simply. The Skywriter, which is you can hover your hand over it and you can assign different events to gestures or how close you are and things like that. The Propeller hat, which is a little prototyping board, and the Explorer hat, which has got a lot of capacitive touch things along the side and some lights here, and you can control motors from these extra pins you have here really easily. And this sort of thing is really helpful to put out there because it means a teacher can pick that up and really simply put together a simple robot or anything that uses motors or capacitive touch. And the great thing about Pi Moroni is that they provide the software libraries in Python. They're not always in Python 3, unfortunately. We always nag them about this, but it's great that we can have this sort of thing readily available. We have another internal project where we've made this weather station. So it's a board that sits on the Pi that has some stuff going off to some other sensors. We've produced this in-house and having it manufactured, and we're sending 1,000 of them to schools around the world to collect weather data and feed into a big database. That's going to be really cool. James Robinson, my colleague, is going to be giving a talk about that later on today. So this was prototyped on a breadboard, just components and looking at different sensors, and then some software running that just reads the sensors, logs it, uses a database, that kind of thing. We have this is kind of our headline project of the year. AstroPi, if you haven't heard of it, is that we're sending 2 Raspberry Pis to the International Space Station at the end of this year. British ESA astronaut Tim Peake is going to be going up in December, and he's taking these 2 Raspberry Pis with him. He's going to be doing some educational outreach as part of his 6 months in space. So there's some kind of general education stuff. They're sending some rocket seeds into space and bringing them back, and then distributing them to schools for them to experiment with growing the seeds to compare seeds that have been in space with regular seeds that haven't been in space, to see if there's any difference in their growth, and for them to start thinking about space more. And another program is this AstroPi competition, which is we've built this sensor board, which sits a hat that goes on the Pi, and there's a competition for kids to write code for this sensor board that they will pick the winners and run that code in space. So primary school and secondary school kids in the UK have had a chance this year to have their code run in space. The AstroPi board, we call it the Sense hat. This is what it looks like. So we've got a little 8x8 grid. That's an RGB LED matrix. It's got a bunch of sensors, so you can get the temperature, humidity, pressure, accelerometer, gyroscope, magnetometer, and it also has a mini joystick for input. We've been through a lot of testing of getting this hardware suitably acceptable for space, for flight in space, and it's gone through all sorts of vibration testing and all sorts of things to make sure that it's safe to be in orbit. It's going to be mounted on the wall in one of the modules on the ISS, and it's going to be there after Tim Peake comes back, so we're hoping to do more things with them once they're up there. This hardware is going to be really handy for a lot of people as well, not just for the competition. So this should be going on sale within the next couple of months. It'll be really handy for a lot of projects. So just to finish off, we've, again, to remind you that we've got this education summit. So have a look at the rest of the talks on this track for the rest of the day. So my colleagues and I and some other people from the community are going to be talking about education, Raspberry Pi, and all sorts of other things. And also at the weekend, we have some sprints. So if anyone wants to come and hack with us on different educational projects, and hopefully we'll have some teachers there and see what they have to say as well. So thanks very much, and I will close for questions.
So, do we have any questions?
Hi Ben, thanks. That was a really good talk. So I'm quite obsessed with space, just as much as I am about programming. Could you tell us a little bit more about the tests you had to actually put the hat through in order to be able to take it up into orbit?
Yeah, so I don't know an awful lot about this because I wasn't part of the testing team, but I kind of hear a lot from it. But we've got a developer called Dave who's been doing all these tests, and he's really keen in telling us all about it. So for the actual launch. So for the shuttle to go up, it vibrates a lot. So they have to make sure that it doesn't break and break apart during the launch. We have to make sure that there's no kind of radioactive materials coming out or anything kind of bad leaking out into the air that could be harmful to the astronauts. They have to kind of shatter one with a hammer or something and see kind of what bits come off and what could be harmful, and test it again after that. And also things like heat, that it doesn't gain excessive heat. I've actually built a special case for it, which is probably the most over-engineered case besides the one that we made recently for general use that's ever been made. That's a great big giant aluminium case that has the matrix, the LED matrix shown, a little hole for the camera, and it's designed in a very specific way for the heat not to radiate, so make sure that it doesn't get hot to the touch or even radiate out.
I liked your talk, and I was just looking at the Raspberry Pi homepage, and so I have a question. Are there any Bluetooth possibilities with the Raspberry Pi?
So there's no built-in Bluetooth on the Raspberry Pi, but you can use a USB dongle. So if you have some Bluetooth device that you can pair with, you can do that. Yeah. I think the Wii remote, the remote for that is Bluetooth, and I've seen people do projects with that, where they're waving the Wii remote around, driving the robot forward, and that kind of thing. So, yeah, it's definitely possible. You just need a USB dongle.
Yes. The code that you showed is actually, it's quite simple, and it's meant for kids to be able to use, of course. But I don't know if the Raspberry Pi has got any sort of visual programming environments for instance, like the logo on the OLPCL X1. I don't know if you've ever seen that. But it's just very simple, just drag and drop things, and then you make the turtle do stuff. But I was actually thinking that with something like physical computing, it would be even nicer to have a physical block dragging or block aggregation programming environment. Do you know of any projects on that direction?
So the Raspberry Pi comes bundled with Scratch. So Scratch is a popular visual block-based programming language. Really good for beginners and really good for young children as their first programming experience, not having to think about syntax or even bothering to type anything, but just being able to click and drag and drop. So that's the Scratch is pre-installed, and there are possibilities for extending that to be able to use GPIO. So you can actually drive robots forward with your drag and drop program in Scratch. We tend to, in our mind, we tend to look at Scratch as the first step. The second step is a really good move above and beyond Scratch called Sonic Pi, which Carrie-Anne discussed this morning. It's based on Ruby, so there's not as much precision required in the syntax, not quite as much as Python. Even though we all like to think Python is great for that, but we see tabs and we see spaces and we see colons. Kids don't really see that stuff. So Sonic Pi is a nice step forward before they get to Python. They can do more. But you can, and there's also Turtle in Python, so that's available as well. So that's another a good one.
Okay, there's no other questions, so thank you very much, Ben.
Thank you. You're using this.
Yeah, I've tested mine works, but I'll just freeze, I'll just use
Oh,
yours.
yeah, whatever. Yeah.
I might just grab some power, actually, my laptop's.
Do you want to borrow this?
Oh, yeah, you've got a
Pointer.
Yeah,
Yeah, there you go.
there's that there. Yeah, that's right.
35 minutes to talk.
Yeah.
5 minutes for questions, then 5 minutes for the mood.
Yeah, that's brilliant. That's cool. If I'm probably going to underrun, if anything, but we'll see. We'll see how I go.
Underrunning is good. It's when people start running late. I start getting
Yeah,
stressed.
I will.
I gotta kick them up the street.
I will. I'm hoping to fill the time. But we'll see. Let's just make sure this is working. I've just made a last-minute change. Yeah, that's good. There we go. No. It's PyCon then with the station at 3:15.
Yesterday, and I waved the 1 minute sign at them, and I looked at it and they went, "Oh, 5 minutes to get them."
Oh no.
Okay, we've time for one question.
Yeah. Okay. I mean, I don't know whether we wait till 1:45 or what. I don't know. Just.
We have to wait for time.
That's fine. Yeah, just give me a shout. Ooh, that's horrible. Do I need to set the lectern? Can I move around a bit? I'll shout. It's fine. I'll check. I'll check. Oh, the camera's fixed. Right. Okay. I'll stay here then. Right. Okay. I'll try. And if I wander, just get back here. Yeah. Just tell me. My teaching pacing. No, it's fine. It's fine. Honestly, I'm just a fidgeter. Yeah.
Okay, good morning again, everybody. We now have James Robinson, and he's going to talk to us from a teacher's perspective.
Thank you. Good morning. My name is James. I'm an ex-teacher, and I now work for the Raspberry Pi Foundation. And I want to talk to you a little bit today about PyCon UK, and in particular the education track that I attended last year. Just before I get started, I'm imagining that the majority of the audience are developers. Is that the case? Are there any teachers or educators in the room? Awesome. So we've got some educators. Awesome. So I want to talk a bit about PyCon UK, and to do that, I'm going to just step back a little bit, and I will be re-emphasising a few points that Carrie-Anne made in her keynote this morning. But I want to just step back to how I began as a learner. So sometime in the 80s, and we'll keep that vague, I was embarking upon my early education, and my mum particularly was very good at supporting me with just exploring the world and finding out things. And she'd often come home and I'd have a theory at 4 about how gravity worked, and it was wrong. You know, she'd come home and I'd greet her with a theory. But I was as kids are, I was keen to investigate. I liked playing with things, and so the things that informed my early education were things like Lego, which I played with for hours on end, followed the manuals. I don't think I had that set. I think I coveted that set. I think I had the smaller version. About the age of 8, I think we got our first family computer. We got the cheaper version of the Commodore 64. This is the Atari 65XE. Technically, it was a family computer, but my siblings knew that really it was mine, and I made that very abundantly clear. And I began, after playing some games, I started using BASIC and writing some very simple programs. And I was also really into craft. Anything, you know, glue, scissors, cardboard, I'd make anything. And I'll come back to this idea in just a second, but I also progressed from basic Lego, I progressed to Technic. And Technic I loved, and still love. You know, I got Technic this year for my birthday, and that was the best present that I got. It was awesome. Our house has been packed up as we're doing an extension. My Lego came out, and I was brilliant. There's my crane thing. But for me, the point with Lego was I didn't just learn about how to connect things. It taught me about mechanical systems. The first kit I got that had a differential gearing, I was like, this is amazing. Now I understand how a car works. Brilliant. And so I learned so many things from these. Again, that's a set I coveted and bought when I was 25. So Lego really informed my early years as well. Knitting was something that my mum taught me quite early on. I lost the skill and have recently almost picked it back up again. I was on a recent trip and I took some knitting with me. And I, as well as starting out with some basic programming, I picked up some of the Osborne books, which were fantastic. And I specifically remember this book and a battleship-style game that I built. And the point I want to make about these education experiences, these were, you know, before school or sort of on top of the stuff I was doing at school, is that all of them were playful. All of them I approached in a playful manner, okay? And every single one of them I could put down at any moment. I could make something in Lego and go, don't like that, I'll throw it away, okay? And this kind of comes back, when we were talking about IDEs during the keynote, one of the things that I sort of really wanted to bring up at that point was that when you've got to use an IDE and you've got to make a project, you're committing to making a project. Whereas if you've got this nice sort of boilerplate, scratch pad style area, you're playing. You can play, as kids do, and then just chuck it away. Okay? The other thing about these learning experiences was there was purpose. There was something that I wanted to get out, something that meant something to me. It wasn't someone telling me to do something. I wanted to build that airport. I wanted to knit something. I wanted to build the Technic thing, and I wanted my game to work, and was frustrated when it didn't. And the final thing was that there was progression. There was always somewhere for me to go next. So I started out with Print Hello World, and I exhausted all the examples in the Atari manual that came with it. But then I found somewhere else to go. Lego, there's just so many places you can take that, and there's so many crafts out there. There's always somewhere new to go. So those three things, playfulness, progression, and purpose, are something that I think is really important in educational experiences. And there's a middle section to my life where I went to university, did computer science, lots of interesting anecdotes involving me mainly losing stuff. That doesn't happen anymore. I'm a reformed character. But then this was me as an educator. So I've moved on from being a learner, and in 2004 I started a career in teaching. So I started my time as a maths teacher, and as someone who could use a computer, and there was an outgoing head of ICT, picked up this role and really enjoyed doing it. It was a great experience. But I did get quite quickly frustrated with ICT, and this again echoes some of the points that Carrie-Anne was making earlier. A lot of ICT was being driven by Office app-based programming, was limited to Excel, macros, and formula. And a lot of the engaging and difficult, also what I would describe as engaging, and what a lot of teachers might consider difficult concepts or activities, were left to the end of the year. A lot of primary school teachers that I was sort of talking to around the time was, oh yeah, we do Lego robotics and we program them in like the summer term. Sometimes we don't get the full 6 weeks that we allot, sometimes we do a week. Because it was those things they'd leave to the end as the fun activity to end the year, and then at the end of the year, oh, it fell off the end of the year, never mind, we'll do it next year. And those kind of experiences were always being left to the end. So as I started, I was sort of kind of really trying to change the way that I was doing things in school. I managed to convince the school to buy some Lego robotics. We started a Lego club. We entered the first Lego League. Games Factory. Has anyone ever used Games Factory? It doesn't really exist anymore. But that's where I started. I remember hanging out in a shop in my local town called Microfuture, where they had this system called Click and Play. And it was a drag and drop games engine. You put a sprite in, you pressed a button, and it pinged around and bounced off walls. And that was our starting point. And they developed it into an education product. And I used that in school. It was really good. Scratch, again, lots of Scratch stuff, simulating games, those kind of things. And we also tried to do some HTML. There was some HTML before. Sorry, I keep turning and the microphone keeps losing me. I'm a fidgeter. So HTML was something that the school had previously done through like Front Page or Dreamweaver or something like that. And I think you start using those big heavy IDEs and you start losing the basics of how that works. That's not how I learned HTML. I learned HTML with a notepad in one window, a browser in another window, save, refresh, save, refresh, save, refresh. So we did some basic HTML stuff. And I moved on. I went to a secondary school, but I began collaborating. And this is the point where I think things changed a lot for me. Because those frustrations that I had in school, being the only teacher who kind of, in my mind, got it, was really difficult. So starting to connect with other teachers was really important. I joined CAS, which is a group in the UK called Computing at Schools. I started working with local primaries, helping them deliver robotics in their schools. And then, all of a sudden, it was a few years ago, it was possible to teach the GCSE in computer science. So there was a pilot phase, and there was a phase where teachers could pick it up. And I was super excited by this, because this was finally, all these things that I've been banging on about were going to happen, and I could pick this up. And I was really excited. And then I suddenly realized, well, actually, how am I going to deliver this? What's my route to deliver this with kids? And the first question was, what language? And that sort of, again, like we mentioned earlier on in the keynote, this took me back to my childhood experiences using BASIC, and Python was really the clear choice for me. And there was this whole sort of, how do I teach this? How do I go about sharing this with kids? I know how to write a loop or write a function or do this and that. But to me, it seems self-evident. How do I break that down and take my understanding and get it across to the kids? And how do I challenge kids? I had a kid in my first GCSE class who'd been programming since the age of 5 and had never stopped. Unlike me, but when I was a kid, we didn't have the internet. We were very late getting the internet. Eventually, I convinced my dad to buy us a 3-month trial of this internet thing. We got on there, and suddenly, my horizons were expanded. But he'd been learning Python for years, and C and Java. And he was at the time he came to my classroom, he was a far better programmer than I think I will ever be. So how do I challenge kids like that have this experience? Because there is, unlike traditional subjects, there is this difference of experience. Some kids would have been doing this for years and years and years and have a wealth of experience, and it will just click. And other kids might be aware of it or might have been put off by it in the past. So whereas in other subjects you might have a fairly level playing field, you've got a whole different range of experiences. So the collaboration with other teachers was imperative, was really important, and it was around that time that I gave a talk at Raspberry Jam I met Carrie-Anne shortly afterwards, went to Pi Academy, joined Twitter, went to more CAS conferences and things, and that was the point at which I became aware of PyCon UK, and submitted my application hurriedly because there was a deadline, and if you quit, you'll get a free place, and they'll fund your cover costs. So great, yeah, I'll do that. And so that's how I got to PyCon UK. So PyCon UK was a fantastic experience for me. It was last September, and particularly the education track, which is where I spent my day. Unfortunately, I had just moved house, and so I had a wall to go and knock down or something at home, so I could only stay for the Friday. But there was a 2-day track. The first day, the Teachers' Day, was brilliant, and I'll talk a bit more about how these worked in a moment. The second day was a Kids' Day, and developers were welcome to come to both of those 2 days, encouraged to come to both of those 2 days. In fact, there's a picture somewhere of Nick in a minute. I think it's the first picture I've got on here. Yeah, there's Nick saying, "Go to the education track. You should be there." And so it was fantastic. It was filled with workshops, demos, training, discussions, quadcopters towards the end of the day, and cake, which, you know, which is going to get anyone there, really. And the cake's here. If they don't whet your appetite, nothing. They're amazing. We were joined by members of the Raspberry Pi team. So Dave is in the bottom right-hand corner. He's not with us today. He's the guy that Ben was previously talking about, who is doing loads of space stuff. We've got Ben, we've got Carrie-Anne, and we've got Alex, who's down here with us as well. And there's the cake. Yeah, so the cake was amazing. So one of a teacher that I hadn't met at this point, but I was aware of from Twitter, called Kat. She'd been on a following the Pi Academy after me. And we'd sort of been chatting a little bit on Twitter, and she was like, "I'm going to bring cake." So she turned up with this cake, and it just vanished. I think I saw it at the beginning of the day, and then by halfway through the day, I was like, "Where's that cake gone?" And there was one cake left. So it was a fantastic day. The link at the bottom, I've nicked a few things from Nick Tolloway's excellent introduction to PyCon UK. If you want to have a more detailed overview of the 2 days, you can follow that link, and that will take you there. And we were also joined by members of the community. I forgot to thank 2 people at the beginning of the presentation. This is Alan O'Donoghue, who, along with Nick, provided some last minute a lot of the images that I've used in this presentation, because I had some camera failure issues. So, so loads of community people that had given up their time to come along to talk about education, how we educate, and the projects that we should be focusing on. So this was sort of how the Teachers' Day was broken down. So first of all, we can see we've had a session on Minecraft Pi, and we can see all the teachers worshipping Minecraft there. Or Martin, I'm not entirely sure. So this guy you can see standing at the front there, this is Martin. He's got an excellent website, Stuff About Code. And that's how he usually starts his workshop, with okay, please, pay your respects, worship, that kind of thing. So, and he gave everyone a little demonstration of how to use the Python library to interface with Minecraft and create amazing things. And if you think back to that, the first point I made about my early experiences with Lego, Minecraft is often described as digital Lego, okay? This playground, this area where kids can play. And I don't see Minecraft, when we talk to teachers, I don't try and put Minecraft across as, oh, here's a game. Minecraft for me in education is a medium. It's a way of expressing things. The idea we talked about earlier on, the story about, oh, we want a game where we've got, it's set on a planet and there's aliens and you shoot them. Well, with things like 2D graphics, Pi game, to get kids to make something graphical, I never bothered with my GCSE kids because it was just it was more of an A-level topic anyway. But for the amount of time they had to put in to get something simple, graphical on the screen, it just, Pi game just wasn't worth playing with at that time. Minecraft, we can build all sorts of things with Minecraft. So we set my kids in school a challenge. We said, go away and I want you to build Space Invader, and they went away and they did that. They built Space Invaders, but then they turned those into flashing Space Invaders, Space Invaders that chased you, Space Invaders that dropped things on your head, Space Invaders that chased you. They hid Space Invaders around the world, and you had to go and find them. So Minecraft is a medium, and this workshop was fantastic. And there were loads of people. It was their first experience of Minecraft, first experience of programming, and they loved that. There was a session we had all about physical computing, so some of the things that Ben's just been talking about in his talk. There was a session, flashing LEDs, using motors, we had some spinning flowers and bees, is that right? Yeah. Okay, I wasn't in that session. There was a bit of a split at that point, but there was some physical computing. We also had a session with an introduction for secondary teachers, particularly to object orientation. For lots of those teachers, object orientation was something they might encounter with libraries that they're using, but wasn't something they were overly familiar with, or wasn't something that they had used for ever or for a long time. So it was a great introduction or refresher. We had a team brought over some, oh, it's gone too far. Oh dear. There's a robot there, it's going to disappear. So the robot there is it's called a Now robot, and a team brought those over. They danced, they sang, they did all kinds of clever things. You could take them for walks, and they talked about their programming interface behind that and how schools should be doing more robotics. And then the afternoon session, we had an unconference style session. So we started off, we got all the teachers and developers together, we pitched some ideas, and then we all broke off into groups, and we kind of worked together as teachers and developers to either do some resource development. So I want a resource that helps me teach this concept. Let's go and make it together. Brilliant. Or perhaps some coaching. So there was a lady who wanted some help with, I think she was doing some web stuff, and she wanted some help with Django. That rings a vague bell. And so she sat down with a developer who helped her understand how Django works and write the beginning or the framework for a scheme of work to take back with her kids. And there was people that were sort of talking about how to make some libraries or some tools. So this screen here, there's a thing for one of the GCSEs. They have to do a project on Little Man Computer. Are you guys aware of Little Man Computer? Okay, it's kind of, I don't teach that spec, partly because I don't like Little Man Computer. But I think it's basically, it's a simulator to help you teach kids machine code type, like very low level code stuff. So very basic operations and instructions. And the complaint from one of the teachers was, at the moment, this doesn't run on the Raspberry Pi and we're using them. So they sat down with some developers and they ported it to the Raspberry Pi. Okay? And that was like an afternoon's work for a developer. So this bit, the second part of the day, was really, really valuable because they gave the teachers the chance to direct the help, the support they needed. And I think this collaboration is really important. So if we think about the first group of people that are there, the teachers, okay? The teachers, they're really great at delivery, okay? They've got years of experience of doing that. They know how to take a concept, to break it down into parts, to work out how to deliver that, to explain that, to get that idea across. They're also great at that sort of idea of progression. So this is your starting point. We want to teach you this concept. What's the pathway that we're going to take to get there? They're great at assessing, knowing where kids are up to, and sort of getting a really good measure of what kids understand, what they haven't grasped, and what their next steps are. And they're also good at engaging pupils. You know, it's their job. It's part of what they do. But what they need help with, and this is going back to my experience as a classroom teacher, what we often need help with is our background knowledge. Okay? I programmed as a kid, I did bits as I was growing up. I did a computer science degree where I did bits of Java, but it was more systems kind of based. I haven't done programming, for a long time. And so my knowledge is rusty. So having that support, and some people don't have that background at all. They need more support. They maybe need some help with exploring possibilities, knowing what is out there that can help them. So they want to solve a particular problem, or they wonder if, can I do this with code? You guys, the developers, you're the people to ask. Relevance. A lot of the sort of teaching materials that were out there, first of all, for teaching computer science was, right, well, here we're going to do a little maths game where you guess the number and we're going to use some selection to see if you're right or wrong. Or here's a teacher tool we're going to write a piece of code which if you put in a score, it's going to tell you what your grade was. Which students are going to care about that? They're not. It's not particularly relevant to them. But developers, you're out there writing software, doing all kinds of cool things on things that kids might be aware of, whether it's robotics or web interfaces or whatever. You've got relevant experience that can show kids cool things. And also challenging pupils. The 16-year-old that I had that was a far better programmer than I, talking to developers means that I can find ways of extending them, pushing them forward, and finding new ways to challenge them. And enabling learners. So this kind of comes down to the barriers point that we talked about a little bit earlier on. As a teacher, there's lots of little frustrations that we have, either to do with network administration, the interface we're using, the libraries. Those problems it's good for us to be able to air those somewhere and have those conversations. And developers, so you guys are great at creating solutions. It's what you do. Here's a problem, create a solution to solve that, okay? You've got the really in-depth, detailed knowledge about how the libraries work, how they interconnect, how we can use them. You're great at writing libraries and tools that teachers can take into their classroom. And as I mentioned, you've also got that relevance, that experience which is current, which is relevant, which is sort of real-world stuff. But perhaps what we can help with as teachers is finding new ways to engage learners. So that idea that you have about how, this cool thing that we could do, we can maybe work out how to make that more engaging for learners. And making Python more accessible. The reason I chose Python for its simplicity and its accessibility, I think that Python should be almost the de facto language, the text-based language that kids are using. And in the UK, it kind of is. Lots of kids in the UK, lots of teachers in the UK have chosen Python based on other teachers' recommendations. Whereas in the States, we went over there recently, and it's, Python is used a little bit in education, but not as much as C and Java and processing and JavaScript, which I find weird because they're just so syntax heavy. So that's what I think those two groups bring to it. So the teachers, we kind of help sort of sort that progression, the bit I was talking about from the learning experience earlier on, the progression of how we get from A to B. Developers, you're great at bringing the purpose, the projects, those kind of things. But the bit that's missing is the playfulness. And that's where day 2 comes in. So day 2 was the bit that I missed. And this was, I saw pictures the next day of all the stuff that was going on. And I really wished I could have been there rather than knocking down a wall or whatever. So I nicked some pictures from Nick's presentation, but it just kind of shows you the journey that kids go through. Okay, so here's some kids sitting down at a computer. They're doing some coding. I've got no idea what it is they're doing, but they're doing some Python. It might be Minecraft, it might be GPO, whatever. And you can see there's a slight look of anxiety maybe in a couple, they're a bit unsure. There's one hand on the keyboard. There's a few little things we can notice there. A few minutes later, everyone's trying to get hold of the keyboard, the mouse. They're all having a go. And this comes back to the point that Carrie mentioned in her keynote, that kids are inherently sort of investigative and playful and want to learn, okay? And they probably, there is a whole series, there's like 10 photos in this series, and they go through a range of emotions, like every human emotion you can almost imagine. There's despair when it doesn't work, and all kinds of things going on. But then we get this moment at the end, where they've solved that problem, they've got through all those little barriers, they've worked out what the problem is, they've solved it, and the look of satisfaction on their face is fantastic, okay? And that's why we should be getting together as educationalists and developers to support these guys, okay? To make sure that they're having this experience with coding. That they very quickly, they don't hit that point, the first picture, and stop, but they're able to get to this point where they see the value, they get the gratification from coding. I've got no idea how I'm doing for time, so I'm probably running a little bit short, so I'll move on, but anyway. So what's in it for the different groups? So first of all, it's fun, okay? Whether you're a teacher, a developer, or a kid coming to a Python education event, it's tremendous fun, huge fun. We've got a picture up here, and the first picture, you can't really see it. One of the teachers that was on the course, Sway, this was one of her tweets. Shortly afterwards, she tweeted, "Oh, I've just written something in Minecraft. I'm having so much fun. Yay." Okay? Here are some developers who are helping us out on the day. Again, smiling developers, having fun, enjoying themselves. Okay? Doing something playful and creative. And here we've got the kids just in awe, probably of Ben. I'm not sure what was going on there. Were you talking at that point? I'm not sure. So the teachers, what they get is they get coaching, support, confidence building, and that's really important. So many teachers did not have the background that I had, playing with code at a young age and having a little bit of experience of it. And that confidence is really important for them. They get ideas for lessons. They collaborate with other teachers. They collaborate with you guys. They collaborate with the kids, which, in fairness, is actually where some of these ideas should be coming from. Okay? Because I don't want to teach kids how to do something that I want to do. Because that's my passion, not theirs. I want them to be leading things. So actually getting together with the kids, they come up with a good idea, you're like, awesome, let's make that happen, right? So we might get some new tools or contacts out of that, building our network. Developers, you get to adopt a teacher, right? which is awesome. So I had this experience. I sat down with some developers, and my project wasn't particularly to do with a scheme of work or a learning issue. It was more to do with enabling my use of GitHub in the classroom. So I sat down with some developers, and I said, what I want is I want to be able to push things to GitHub, but it be private. I want like a local kind of GitHub. We found GitLab, which we played around with a little bit. And then what I want is I want like an automatic backup mechanism from my pies, so it pushes there, and then I've just got a repository that I can comment on and collaborate with the kids for. And we started some excellent discussions. We played around with some ideas. They kind of adopted me for the day. And unfortunately, shortly after PyCon, that kind of contact, those conversations very soon disappeared. Now, it's perfectly understandable. Developers have day jobs. I'm a teacher. I'm back in the classroom, and doing things. So it's difficult. But if you are going to do this, adopting a teacher, it's really fantastic if you can maintain that relationship, because it is really beneficial to both. And I'll explain why both in just a second. So you get to engage teachers and kids with the Python community, which is a fantastic community, and we need to get the teachers and kids engaged within that. You get that warm, fuzzy feeling, right, which is great. But also this point, it reinforces, and I'm paraphrasing Nick Tolliver here a little bit, it reinforces a deeper understanding of your own clarity of thought. Okay, so just to unpick that a little bit. When I was a maths teacher, and I said to a kid, right, well, I don't know, here's this mathematical concept, and the kid would say, well, why? Why is that the case? And I go, well, it is. Because it is. I don't know how to break that down any further. And that was me at the beginning of my teaching career. Not being able to understand that some things aren't self-evident. Okay? At that point, my knowledge of mathematics was not deep enough that I could explain that concept to a child. Okay? So being able to explain things to people that are non-experts, being able to unpick why things are, to you, maybe self-evident, actually gives you a deeper understanding, okay? And gives you a better clarity of thought. And the kids, what the kids get is they get a safe place to play and learn, okay? There's no measuring their progress, there's no sort of feeding back on what they're doing apart from in a positive way. Oh, that didn't work, brilliant, try this, have a go, okay? So they're supported, they're encouraged, and so on. They get to collaborate with others, and that's teachers, that's kids. Lots of kids don't get a chance to collaborate with adults. So that's fantastic. Lots of kids don't get a chance to collaborate with other groups of kids. So bringing them all together on this kind of day means they get that opportunity. And they get that sense of pride and achievement. I found a photo last night, but I couldn't put it back up here. There's a picture of Nick standing at the front with a kid and a robot. And the kid is just beaming because he's sharing his robotic creation with an audience. So they get that sense of, I have achieved something, I have done something, I am part of something. And that's, again, really powerful for the kids. And did I mention the cake? Because that was great, okay? So I'm going to just take a brief pause. This is another perspective. This was a teacher that I'd met on Twitter. I met for the first time at PyCon, sat down, caught up, chatted with her. She sent me this, because this was her point of view. So I'm going to shut up for a second and just give you a chance to read what her thoughts were. And I think there's a couple of points in there. Sorry if you're still reading on, but I'm going to just move on a little bit. A couple of points in here. She regards herself as a relatively knowledgeable computing teacher, but really needs that support or values that support from developers. And what her kids need is something exciting which will inspire them. And teachers don't have a huge amount of time. Okay, the working week is very long. And so anything that developers can do, or other people within the community to say, here's this really cool thing, by the way. Like I went to a CAS conference and I was shown, here's a library that you can use, which if you just run a command, it will, it would access the tube times, right? Which is, it's not super exciting, but it's way more exciting than like just crunching a few numbers arbitrarily in a fairly trite example. So this is really, really powerful. And there's a link there Sway wrote a whole blog post all about her experiences of PyCon. I recommend that if you're interested, you check that out. There we go. So how can you help? And again, I will be reiterating a few points from Carrie-Anne's talk earlier on. So firstly, the adopt a teacher, right? And that doesn't have to be through a PyCon event or any kind of physical face-to-face meetup. In your local area, wherever you are, find out what your teachers are doing in terms of computing, programming, that kind of side of the curriculum. Find out if you can support them. Can you go in and, I don't know, I think my next point is talk about computing in your local school. Go and talk about the fun bits about, your day job, right? Go and explain the cool things that you do with code and how it empowers you and what you love about it. Help develop tools and libraries that support learners. And again, we've got that, you've got the homework that Carrie-Anne set, and so we should all be working on that. Okay. Run a workshop or a talk for educators, and again, that could be at an event like PyCon. It could be at a local networking meeting. It could be that if you run like a local Python interest group type thing, invite some teachers, get them to come along and find out what Python's all about. Have they got questions about Python and how to use it in their classroom? Code Club. I don't know if how many people are aware of Code Club or how you access them, but Code Club is a great resource. It enables kind of a partnering scheme for getting experts to go into schools, work with kids, run sort of workshops. And that's great because it means that the teacher doesn't have to. They can attend and support you, but they don't have to be providing all the material. You get a chance to network. It gives you an in. Sometimes it can be difficult from the outside to get in with a school. Going via something like a Code Club might be the way to do that. And there's probably a whole ton of things that we've not thought of, like amazing things that you could do to help engage kids and teachers, with the Python community and with the language itself. So if you've got any other cool ideas, come and find anyone from Raspberry Pi Education team, come and chat with us. If you've got an idea about something you'd like to do, then we're happy to have that conversation. And then I've left some time for questions. So there we go. Thank you.
Thanks for your talk. It was very interesting. I liked the Kids Day thing. Do you know how old the kids were?
I'm going to have to defer to Nick, who was organising it. What was the range of the kids there, Nick?
The youngest was about 5 years old, and they went to 18.
And I think that's important as well, that it's not limited on age, because it means that the older kids can mentor the younger kids, and the younger kids can mentor the older kids. And there's lots of great opportunities for that collaboration. Nick, go on.
Sorry, I've got my hand up. I feel like I'm a child at a primary school. So those photos of the children that we saw programming in the series of the longer series of photos, actually the kid in the middle in the last one, he came along and mentored the other two. So they had a problem. He came along. There's a picture of him pointing at the screen, and then something goes wrong, and then all together they put it right. So the other important thing about this slide is that there are no adults involved in this learning as well. This is autonomous, kids picking it up for themselves.
I think that's an important point as well, is as adults knowing when to step in. So in a classroom, I would often encourage the kids to sort of make their first few steps by themselves and only ask me for help when they hit 3 or 4 problems, because otherwise they feel they have to defer to that adult. Yeah.
All right, thanks very much, James.
Thank you. I think you it's hard. It's hard because you need to.
Yeah. Yeah. You want to go and find one?
Yeah, do you want to? I don't have any cell taking this on, so I'll do this with obvious hand in front of the apple.
All right, fine.
So yeah, there's only one connector.
We might have to swap to doing the presentation from your laptop. Because I think I've lost my graphicsy dongle.
But I have a Mac here, and
You've got one of those.
get one of those.
No, they've got one of those. Yeah, of course. Damn it. Yeah. Check that these things have got one of them. Okay, then I think we're going to have to do that.
Okay.
Damn it.
So I'll need your laptop to do my side then.
Okay.
Charging here.
All right. Does it need charging?
Pretty old batteries, so basically plug it in with the battery's a bit dodgy. If I take yours. Are you online with anything here? At least the
Okay. We don't need a what transition period? Okay, great. All right. These on? Hello. All right. So what happens?
This is switched on. Okay, gracias. Oops. Yep.
Python Anywhere and education.
All right, guys, talk amongst yourselves. It'll be about 3 more minutes. Charles, the students. So shall I log them out and do? This is now connected, so that's nice. I think I can switch the Wi-Fi off. So I should log in as. All right, don't get too excited. All right, good. So that's on purpose. All right, I just know what I'm doing now. All right.
Python anywhere except on a Mac.
Okay, so we can probably. All right, I think we're ready.
We have Harry and Giles who are going to talk about Python Anywhere and education.
Charles. All right. So I'm sure you'll all be happy to hear that this is a sponsored talk, also known as a thinly disguised marketing pitch. Boo, hiss, boo, boo, boo. Okay, so if you would like to leave the room at this point, like this gentleman, there's a much better talk on NumPy. Just make your excuses. We won't be offended. We totally understand. But in order to expiate our own guilt and make this as good for you as possible, we'll promise several things. First of all, everything we're going to show you today is entirely free and will always be free, so it's just out there for you guys. And then secondly, we're going to do the entire presentation through the medium of interpretive dance. Not really. It will instead be through the medium of a small sketch show. So we'll introduce the cast of characters. I am an enthusiastic teacher, brimming with excitement at trying to teach Python skills and programming skills to bright students.
And I'm a very smart but totally new to programming student.
There you go. Come a little bit this way, Giles. You'll be in video range that way.
That's not a good idea.
Okay. So, all right, Giles. Let's get Python installed, and we can start learning to program. If you just pop on over to the Python website, download and then install Python on your laptop.
Okay. I think I've got it installed. So how do I start programming?
Right, okay, so just open up, a terminal and type Python, and you'll get the Python prompt.
No, it says command not found.
Okay. So listen, Giles, when you downloaded the DMG Mac installer thing, did you drag that to the applications
No,
folder?
I'm on a PC, I'm not on a Mac.
Of course he is. All the students have got PCs. Right, okay, so Google's frantically. Right, I think if you have managed to install Python correctly, it says here that you have to add Python to the path, because although that is an option in the Python installer these days, which is wonderful, that's unticked by default. So what you need to do, Giles, is just add the Python's directories to the path environment variable,
I have no idea what you just said there, Harry.
Okay, all right, okay. Installs Windows onto virtual machine, tries to get XP working. Right, it looks like what you need to do is click the Start button, then you go to Control Panel,
okay.
then you go to System Settings, then you go to Advanced Settings, then you find
Advanced
the
settings,
entry,
wow.
yes, you find the entry called path, right, which is a long string of text characters, and then you need to add this, okay? So you have to type this right.
Okay.
C:\\/ Python 3.4 / semicolon C:\/ Python 3.4 / scripts semicolon, and then the rest of the text that was already there.
But Harry, you just said 3.4, right?
Yeah, 3.4, yeah.
No, but my friend Jane said that 2.7 is the one that everyone uses. That 3.4 is just some fancy thing that nobody actually uses. So that's when I downloaded and installed. Should I put 2.7 instead?
Yeah, okay, all right, yes, no, we do need to use 3.4, and now cue a massive rewind as we go back to the start of this story and do it again, except this time with Python 3.4. Although, of course, that then introduces the fun of installing two different versions of Python on the same system, which you might be able to get working on Linux, but on a PC, finding one executable that's going to be Python 3 in Python, as we all know, is not necessarily the easiest. But let's suppose that we get more or less to the end of that. We've got the right version of Python installed, haven't we, Giles?
I hope so.
Good. So let's try some programming. So in your Python prompt, will you type for me, type exactly this, it's important that you have to have the syntax right, print, open brackets, quote, hello world, close quote, close brackets. All right, and if you do that, it should actually print something out to the screen. What does it?
Yeah, it prints something out.
What does it say?
It says syntax error.
Right, okay. All right, well, why don't we just come over there and take a look over your shoulder, and then maybe I can see what you've typed, and I'll be able to help.
But you've kind of forgotten we're in totally different countries.
Oh, that's right. We're in different countries. I can't go and look over your shoulder. Boy, this makes debugging your issues a lot harder.
Yeah. So, Harry,
Yeah?
I'm actually no longer a PC user. I've suddenly become a Mac user. And actually, in the interest of gender balance, I'm now a lady called Gilesalina. And I've also been told that because I'm doing this astrophysics stuff, I need this external package called SciPy, something like that.
Okay. Right, well, now we've got the nightmare of trying to get pip installs and compilers working, but at least Giles is on a Unix platform, a nice Mac, and they just work, right? So I should have much fewer issues getting Python working than I do on a PC, right?
Yeah, kind of.
Kinda? Why?
Well,
Why, Giles? What's wrong?
Well, I installed both Python 2 and Python 3 on the Mac as well. But unfortunately, they didn't work. And then one of my friends said that this thing called Homebrew was better. So I installed Python with that. And now I've got 3 Python interpreters. When I run pip to pip install stuff, I don't know which version of Python it's installing to, but it's not the one I want. And when I run pip3, I get loads of permission errors because I read on Stack Overflow, you should always run it with sudo. So I did that once. Now everything's owned by root. And I can't install anything. I can't even run anything.
Okay. All right. I'm sure we can sort this all out, actually, because there is a Python 3.4 solution to this. There's the ensure pip module, isn't it? Which should be able to bootstrap and download the pip for you, and there's the venv module for you. So that should work. I think that's probably foolproof, isn't it? So let's go ensure pip. What?
Well, it might be, but now I've magically transformed again, and I'm actually a Debian user.
Oh.
And ensure pip doesn't work because the package maintainers have decided that the required venv module needs to be in a separate package. It's not installed by default, so that doesn't work at all. I've been reading absolutely fascinating mailing list discussion all about this stuff.
I envy the dead. If only there was a better way. So now we rewind. Right back to the beginning of the story. Programming.
So, Harry, I've heard about this website called Python Anywhere, which means I apparently don't have to install Python at all. Should we try that?
Okay, I guess. Why don't I sign up for an account now?
Me too.
All right, this is the bit where the demo gods will be against us or not. Wow, Python Anywhere. Look at its beautiful color scheme. And look at this. The logo is a little snake, but it's made out of Python interpreter chevrons. That is so clever. Log in. Oh, I don't have an account, but I can sign up here. That's nice. What's this? Pricing plans. These all cost money. No, I don't think I'm paying for anything. Beginner account, like everyone does. Username. Haha, I know what this. Harry Rocks. Fine. Email, Harry at... Okay, great. Thank you. Files help. There you go. Yes, Alt-GR, that's what it is. Portuguese keyboard, man. I've never touched this laptop. Okay, password. Password 2. Password 2. I agree to the terms and conditions, and I will read them in detail. Let's have a look. Da-da-da-da. Hooray! Okay, well, it looks like I've been signed up for an account. This sure is a helpful, friendly welcome screen. What do we have to say next? Da-da-da-da. Okay, so Giles, how do we start a Python console?
Well, there's this very large thing in front of me that says consoles, and there's a thing that says Python. Maybe I should click one of those?
Oh, okay, yep, I see them too. Ooh, look at that, they have IPython. Giles, why don't you start an IPython 3.4 console?
Okay.
Oh, just why would the scroll go backwards? No. All right, fine. Okay, good. So you've got IPython in front of you now?
I think I do.
All right, great. So now will you type for me, print, open brackets, open quotes, hello world, close quotes, close brackets, and press enter. And now the Python should print something to the screen for you. What is it printed?
Well,
Does it print
let's see.
something? Sure, print something.
Yeah, it prints something again.
Oh, great. What does it say?
Invalid syntax.
Oh, what shall we do now? Wait, I've heard that Python Anywhere has some education features. Giles,
I've heard that too.
If you navigate over to the accounts page, I think you might be able to specify me as your teacher, and then I'll be able to help you interactively.
Well, let's try that.
I'll show you what it looks like.
It's always a bad idea learning a programming language when you're actually tethered to your Android cell phone. Okay. What was your username, Harry?
It is Harry Rocks. I use that everywhere.
How do I spell that?
HARRYROCKS.
Not with an X.
No.
Okay, I've done that.
Oh, okay, good. Well, let's see if that's registered in the system. Come on, R. Ooh, look at this. Now it's telling me that I'm logged in as Harry Rocks, currently viewing Harry Rocks, but I can switch to viewing Giles the student. Let's have a look at this. Oh, and now I can see Giles has already opened some consoles. I wonder which one of these is the console that he's got a problem with. Look at that. I can just open it up. I can see exactly what Giles has been doing. There you go.
You told me to type exactly what you said, so that's what I did.
All right, what happens next? It's a shame that we have to keep skipping to the script and then people read it. Guys, like, just close your eyes for a minute. There you go.
Harry.
Well, I couldn't print it out. There you go. Okay, right, fine. Okay. All right. So, Giles, I would like to help you fix this.
Okay,
And I mean,
great.
I could explain slowly to you exactly how to print that to do this, but why don't I just demonstrate it to you instead? So, I can type into the console, and we go open brackets, quotes. Yeah, as if I'm going to find some quotes on this keyboard. Quotes? Yes. Hello, EuroPython. Close quotes, which is not even written on that key. Enter. Look at that, Giles. Open
Oh, I
brackets,
see.
open
Now it all
quotes,
becomes clear.
Hello, EuroPython. Wow. Why don't you give that a go for yourself? You can press the up arrow to repeat the previous command and then edit it slightly.
Well, let's try that. Wow, if only I could type.
Amazing. Don't you think the colors in this console are pretty as well, Giles?
Yes, they are.
Round of applause. Congratulations.
But what about that SciPy thing that I was told I needed to use?
Oh, right.
To install that or something?
Oh, God, installing SciPy. I don't know how that's going to happen. I mean, I remember doing this on my own laptop. You had to get a compiler. There's no way that this Python Anywhere thing is going to be able to compile things. We're going to have to, like, download a wheel. I don't know what platform it is. No, Joe, I don't think. Maybe we should just leave the SciPy thing for another time. I don't know.
Well, all the SciPy scripts I've seen start with this magic word, import SciPy. Maybe we could try that. Maybe you could try typing it as well, because my internet connection's just disappeared.
Yeah, okay. I mean, I know that it does say that on the instructions, but the thing is you have to install these things first. So, like, this doesn't work. You have to pip install it. Okay. Yep, looks like it's all there. Wow, SciPy installed by default. All of those installation hassles that I thought I was going to have to deal with are just magically solved for me straight away. Thanks, Python Anywhere. Okay, close your eyes again, everyone. Type success, right? No, you're not
really
closing your eyes. I can hear you guys giggling. Right, okay. All right, fine, good. So, Giles, now, let's do some assignments.
Okay.
Yeah, I'm going to give you an assignment.
Okay. So should we just use the same system as we did before we started using Python anyway? You just email me the assignments, but you just need to remember to tell me exactly where to save the files, because you remember all the problems we had when I tried doing Python, my assignments, and it just didn't work, because you didn't tell me where to install it?
Yeah, okay, that'll work. I mean, yeah.
Okay, and then when I've completed the assignment, I'll do what I usually do. So I'll take a screenshot, I'll put that in a PDF, attach that to a Word document, then email it to you.
Yeah, well, the important thing is that the process works.
Yeah, it does.
Well, Giles, we could do that, but actually, I know that Python Anywhere has education features, and so I'm going to take a look at their documentation and see if there's anything they can do to help with this. What I love about this website is it's got such powerful servers that it doesn't matter how slow the internet connection is, it responds like lightning.
Except on this laptop where it's not working at all.
So, what are we doing here? 5 minutes. We've got, where are we on our little story? I'm reading the documentation and I'm finding out that, oh yes, magically, because I'm a teacher, I can actually access all of Giles's files directly. So, if I was to open up one of our little editors here, and I can go and start a new file, which I'm going to call week3.py. And then, okay, close your eyes. There we go. Command C. Command V. Oh, syntax highlighting, so pretty. There we are, we can save that. Good. Why is he unhappy? It's because there's no pass over here. Look at that. PyFlakes checks built into the editor. So useful for beginners. Come on, save. Console, start a bash console. Goodness me, so I don't have just IPython consoles. I can also start a full bash Linux environment, and everything is in here, and I have ls/, oh God, where is the backslash, Giles? ls/home. I've got my own home directory, and I can see Giles's home directory. So if I copy the week3.py to ... Giles the student, dunk. Maybe that's going to magically appear in Giles's home directory. Let's go and have a look, because I can actually see all Giles's files and folders. So here I am viewing Harry, switch to viewing Giles. I go to his files directory, and look at that, week3.py has magically appeared in Giles's home directory. And now you go on and try and solve the problem.
Shall I do that now while you talk?
Okay. Yeah, why don't you carry on and do that, and while I start thinking about next week's assignment, because next week we have to do web development, and I mean, like, there's lovely frameworks in Python, isn't there? But I also want to get my student to deploy his code on the internet, and if you thought that getting Python installed on a laptop and across multiple platforms was quite difficult, just you try going, what's done? Oh, you've solved the problem?
Yes.
Oh, well done.
Laptop.
Wonderful. Okay, but as I was saying, yeah, God, web development headaches. Had to deal with this a lot. I'm starting to think about where am I going to get a virtual machine from, and I'm going to have to set up user accounts on there, and I need him to do the SSH keygen command and set up an SSH key with a passphrase, so he can do SSH login to the server, and then we're going to have to install Nginx or Apache, certainly not Apache, Nginx, but then we need a front-end web server, so we're going to have Junior Unicorn and get his code. Oh God, he's got to get his code on there, so we're going to have to FTP it up and explain how FTP works, and then once we've got the code on there, we're going to have to install stuff. Probably virtual env, so am I going to have to explain virtual envs? I think I'm just going to have to do it for, because I mean, he's not going to be able to edit all these config files anyway. So, yeah, all right, I will do the editing of the config files on the server as long as I can involve Giles in the process, and then he'll probably be able to see his web app. Oh God, and then I've got to make sure that port 80 is open on the firewall, and then anybody here an Amazon user? Okay, yeah, is it what? Oh my God!
I have a web app.
Okay, everyone, well, that was it. That's pretty much a tour of Python Anywhere. I hope it wasn't too tedious. That was pretty much all of our features. There's a few other things you can do. You can run scheduled tasks. You can blah, blah, blah. We've just started doing education stuff, so we're really interested in getting new people on board. It's all free. And we've had maybe a couple of dozen teachers on there now. So in students, it might be 100 or more.
Yeah, just over 100, I think.
Okay. So like we've got about a couple of dozen teachers on there running classes. We've got a couple of hundred, well, 100 students. They're all using it. But we're really interested in getting new people on there, getting some feedback, getting you guys to suggest new things. What should I say? There are a few limitations, right? This is not the magical solution to everything. One of the first things is this is a server-based computing environment. All the Python here runs on our servers, so they don't have access to any kind of graphics or display. So, I mean, you can build a web application, you can have a lovely text console with colors, but you can't do Turtle, and you can't do Pygame. But for like maybe slightly more advanced students, it's great to be able to do web development easily. And we can also recommend our frenemies at Trinket.io, who've built a sort of browser-based Python sort of sharing platform. And their Python runs in a sort of JavaScript emulator. And they do support Turtle, and they're thinking about supporting Pygame. Good luck to them. But I mean, Trinket is great. Like, it's really easy to share a little snippet, and you can have pictures and stuff, and it makes it really easy to share it between students and things like that. But so that's where we are. We've got, we've got our teachers on board. We've got students. We've got people doing screen sharing. You can share consoles like this. The teacher can have a demo console they share with their students. They can share it read-only. You can exchange files like we sort of demoed. All of these sorts of things. But we're really looking for people to come in and have more suggestions. And we're also really keen to make sure this is a success for our first few teachers. So we're always happy to go the extra mile to do some manual steps. If you're like, oh, I need to bulk register 100 users, we'll do that for you. If you're like, oh, please pre-prepare all of their home folders with this GitHub checkout, we'll do that for you, that sort of stuff. And that's about it, really. So are there, so unless there are any questions, comments, feedback, suggestions straight away, that's what we'd like to take. Hello. And there you go. There's a plant over there. What about you, sir?
So the logistics was one of the things that I thought about. So I have around like 50 students, and I mean, having students with like weird usernames, it would be better if I know who they are,
Yep.
right?
Yeah.
So I use like student response systems, which are online, and I do the registration for them there and give them their password.
Yeah.
So you said that wasn't inside now, but you sort of could do a workaround or something?
Yeah, when we bulk create accounts, either if you give us a load of email addresses, we'll generate a username based on their, the before the @ bit from their email address. Or we can generate randomized usernames, which you probably don't want. Those are the two options currently. And we can also go like your username, then 1, your username 2, yours, yeah, something like that. So have another crack.
Do you do any authentication stuff? Because I mean,
Yeah, we'll generate usernames for you.
No, I mean, but external authentication.
Oh, right, yeah. We haven't done that, but that's on the agenda for pretty soon, isn't it?
Sorry,
Like third-party authentication thing. You want to do, yeah, maybe use their Google accounts or whatever. Yeah. Yeah. We're looking into that, so that might actually happen soon, but I don't want to promise right here. Yeah. Thanks for the suggestion.
Hi, Harry.
Hello.
Hello, Giles. That was a really entertaining talk. So I'm Nicholas, and I work at Snotgrove Comprehensive School in Scunthorpe, and we're on XP with IE6. Can you help me?
Yeah. Yes. No. Yeah. No. Yeah, that's a good point. I mean, like a lot of schools have got, one of the advantages here is that you're going to be able to run Python without installing software on school laptops, and maybe school IT systems are a bit conservative. On the other hand, if they're that conservative that they're stuck on IE6, maybe we really can't help that much. But it's worth a try, so we support more things than we thought. A lot of schools are starting to give out Chromebooks to their students, and then they're like, oh, wonderfully shiny, but no Python. So that's one solution for that as well. Okay. Anything else? Comments, reactions, suggestions on how to improve the talk? Okay. Oh, yeah, brilliant. Yeah. Hide the script. Yeah. We did actually, yeah.
Yeah. So another way that I use Python is during lectures. I have like live demos.
Yeah.
And currently we have this web system which is actually also using Sculpt that Tinker is using.
Yeah.
And that enables me to sort of just give my students a URL.
Yeah.
They get it. They don't have to log in or anything. They can just follow along.
Yeah.
Is that possible with Python Anywhere?
It
Anonymous sort of.
Anonymous console sharing to a wide. Yes. Yeah. We support so the console sharing feature where a teacher can see their students is actually grown out of a previous feature that we built. So anyone can share a console with anyone else on Python Anywhere. And we've also got the ability to share it with anonymous strangers. So if you fill in an email address, we'll send someone an email with a unique URL to that console, and then they can go in on the internet without logging in, and they can see exactly what you're typing into that shell. And so you can send that, you can send that email to a group. And so you can send that to a mailing list, or we could include. Yeah.
So everybody shares.
Yeah, everyone sees the same one, but you can share it read-only, so it's a demo-only thing.
Yeah.
Yeah. Well, so that console, right, yeah, so that console is like a single console for the whole group. So then you've got the sort of read-only settings. If you did have your students all registered in, you can log them all in and then switch read-only on and off for one of them at a time if you want to hand over control to one student and things like that. Are you thinking that it would be nice to be able to share things with students and then they can sort of fork it and go off on their own?
Yeah.
All right, we'll have to think about how to do that. Yeah. Okay. Yeah. Good suggestion.
Then you can give them something like what you
Yeah.
did
Yeah.
earlier. You can give them that to fill in.
Yeah.
But if they all had that to fill
Yeah.
in, they all had their own.
Yeah. All right. I think there's ways and ways to do that, but we could probably make it slicker. Yeah. Good suggestions. Thank you very much. Aha.
Yeah, it looks really great, and there's lots of stuff for free, and I can see it being really brilliant. But obviously, you're a company that makes money, so what are the paid options? What do you get for them? And sort of who's the target demographic for that? Well, because I might be interested, you see.
Yeah, oh, right. Well, if he's interested.
So don't do the evil laugh.
So, good question, obviously. Well, basically, you are the product. No, it's a freemium model, so we just hope to get, so if we have a sort of 10% ratio of users who end up needing the paying features, then we're great. So the education deal is we get a bunch of students used to Python Anywhere, so later on when they want to do some more professional programming, they at least think of us as an option. And then they So at the moment, all the free features is you can start up to 2 consoles at once, so you have to close one if you need more than 2. You can have 500 megs of storage. You can store one web application, which is at your username.pythonanywhere.com, and that's free. But the things you have to pay for is do you want more than 2 consoles? Do you want a greater CPU quota? So we start throttling people after. And it's the equivalent of what's the CPU quota for free users, 500?
100 CPU seconds.
100 CPU seconds. So if you max out the CPU for a minute and a half, we then start throttling it. I mean, not that aggressively, but like if you're really going to use it for serious number crunching, you might want to think about paying for an account. Although a lot of people don't, and we still do run their jobs for them. And finally, if you want to do any web hosting on your own domains, then we ask you to pay for that. So if you want to get away from the Python Anywhere branding. So that's kind of the line at the moment. Charge for Python 2. I like that. Good
All right,
question.
it's out of time. It's time for lunch. So thanks very much, Harry and Giles.
Oops, I did the wrong thing. Oh, well. No? Okay. Gracias.
That actually added to it, I think.
That was brilliant. That really was.
Well, you hadn't learned the script.